And if we do hit net zero emissions, we expect to stop warming the planet. At the moment, we're warming the planet about 0.1 to 0.2 degrees Celsius per decade. We've already warmed the planet overall about 1.2 degrees Celsius relative to pre-industrial levels. We're going to keep warming it as long as we keep emitting greenhouse gases more than we draw down carbon from the atmosphere. If we get to net zero, we stop warming the planet. If we can go negative with our greenhouse gas emissions, so we're actually taking up more than we're emitting, then we start cooling the planet. And that opens up really exciting opportunities if we can get to that point.
Hello and welcome to the Plant Paradigm Podcast, where we have inspiring conversations with amazing individuals from all around the world and look for ways to create a clean, green and sustainable future for us, the planet and all beings. I'm your host, Tom Simak, a fellow plant eater and athlete who is here to facilitate those inspiring conversations. In a few days' time, the monthly Paradigm email will be going out to everyone that's on the, Plant Paradigm email subscriber list. It is a monthly debrief on one key highlight of the month on 3 different topics: health, the environment, and veganism. If you haven't yet joined the gang over there, head to theplantparadigm.com and put in your email address. Now on to today's conversation. It is with climate researcher, Dr. Andrew King. Andrew is a senior lecturer in climate science at the School of Geography, Earth and Atmospheric Sciences and ARC Centre of Excellence for Climate Extremes at the University of Melbourne. Dr. King's work has been cited hundreds of times, and his research has also been published in top journals like Nature. As you can imagine, we're going to be talking about climate change today, the future of society, transitioning to a green economy, utilising these renewable energies, how we can stay under 1.5 degrees, and if Andrew even thinks that is realistic at this stage, a climate scientist, vegetarian or vegan, and we're going to touch on media and the news industry and their role in all of this. I think this was a really powerful episode, and I think everyone who's into the realm of climate science and climate education will really take a few key things out of this conversation that they can go on to their friends and family and then continue on educating society so we can start looking forward to this greener society that we talked about on today's episode. With that being said, I will see you on the other side. Dr. Andrew King, welcome to the Plant Paradigm Podcast. How are you going?
Good, thanks for having me.
An absolute pleasure. We're chatting a bit before the recording went live, and I've got to say, growing up, I used to think this kind of stuff was super boring, like meteorology, like really nerdy, and I guess in a certain way it is. But there's so much to be excited about in terms of what the future looks like, because I don't know about you, but I almost seldom think there is another industry out there where the future is so uncertain.
Yeah, I think, we have very changeable weather, and we've got this background change going on with the planet. Because of our greenhouse gas emissions, we're changing the climate, which means we're changing the weather that we experience. So we've got that variability and we've got changes going on. It's very hard to tell what's going to happen in the next few decades in terms of like extreme weather events we might experience. So even though it's quite a nerdy pursuit, it's quite, I think it's quite an interesting, exciting area to be in.
And definitely noble, especially when this is one of those industries where it actually impacts a lot of lives, especially when it comes to, like you mentioned, actually measuring and tracking these events. Like that's a really big deal. Like if we look at like where we are, we're in Australia. Recently we had these horrific floods that plagued Lismore and the surrounding regions. In the future, or even, I'm not sure how it went this time, is that something we're able to predict?
We can predict to some extent on short time scales whether we're going to get these severe weather events. So, for example, this past summer, we did see lots of severe flooding along the east coast of Australia. And because we had a La Nina event, which is where we have warmer waters in the West Pacific Ocean, that increases the odds of having extreme rain conditions over much of Australia. So we kind of already knew in advance we were likely to see some flood events. But then actually predicting when these events will occur and where these events will occur is quite hard. So they can usually be predicted a few days out to some extent, and then a few hours out with more accuracy. But we do need to kind of improve our ability to forecast really extreme rain events, especially.
What kind of technology do you need to even forecast that kind of stuff, especially as that kind of technology, if the greenhouse gas emissions aren't curbed anytime soon, which they may or may not be, that's arguable, it's going to need a drastic upgrade really soon. And especially if you think that, from my understanding, what's happening in South Africa and their weather patterns actually eventually makes its way through to Australia, and everything. To predict weather, you have to know what's going on around the world. So what kind of utopic systems are we going to need to predict this kind of stuff?
So we do have global weather prediction models. So this is where we basically divide up the atmosphere into lots of boxes, and we model the movement of air and other properties of the atmosphere between these boxes, and we predict what's going to happen next. So we do track the weather systems as they come from our west, from places like South Africa, and then cross the southern Indian Ocean and eventually reach southern Australia. We can predict with reasonable accuracy a few days in advance these weather systems. The problem we have with a lot of severe weather types is that they occur on quite small spatial scales or over quite short times, especially extreme rain events. So if you think of these kind of thunderstorm events where you can get really torrential rain and really bad flooding, they tend to occur, on timescales of minutes to maybe a few hours. And, you may get a storm over you in one place, but then 10 Ks or 20 Ks away, there isn't a storm there. It's actually dry. And predicting where those storms will be is really hard because, just a small error in the prediction means you could have flooding in a different river, in a different basin. So it's really quite hard to predict these events with high accuracy, more than a few hours in advance. And with the Lismore floods, especially the second round of severe floods, were due to a major storm cell coming across. That was quite hard to predict, and it did take some people by surprise as a result. So in terms of kind of what we need, we kind of need our models to continue improving. We need to kind of shrink these grid cells, these boxes in the atmosphere that we model at, so to actually simulate the storms better and to simulate their tracks a bit better. Right.
So what kind of had me thinking while you're talking about, because it's meteorologists, I think, in a large part that make these predictions, and not one, two, but like a group. What I'm curious about is essentially you run it off an algorithm or a calculation or some sort of system. Now that's based on someone's calculation, and if that were to go wrong, is there some sort of table for the meteorologist or that team to be liable for errors in calculations?
So these models are kind of based on established science, and it doesn't really the equations that are used are never wrong. They're just kind of standard sets of equations, including things like Newton's second law of motion, so force equals mass times acceleration, and then a whole set of kind of more complicated equations. So that's not the kind of thing that goes wrong. It's more that the atmosphere is kind of chaotic, just a small change can make a big change down the track, and that just means it's quite hard to make really accurate predictions. And I think on the whole people understand this. There's an appreciation that it is hard to predict extreme weather events, especially like heavy rain events. So we haven't really seen meteorologists be kind of held to account for poor forecasts. It would be very hard to, it's never deliberate, and it's never, it's just because it's quite a complicated thing to try and do in the first place. But yeah, in other fields of science, we have seen attempts to make hold scientists liable for poor predictions or lack of prediction. So we saw that with an earthquake in Italy quite a few years ago, for example. That was very controversial. So there is, because there is so much cost associated with extreme events, we need to be able to predict them well. But I think most people understand it's hard, and we're trying our best.
Yeah, for sure. I think certain fields, to be fair, need that scrutiny, but one field such as meteorology, where there's so much what you see, there's lots of extraneous variables. There's just one, it's like that joke, one butterfly could change, that little swell they make with their wings, and changes their pattern and air pattern, and kind of goes on like that. But there's a lot I wanted to touch on. And first, since we're in Melbourne, I wanted to kind of see what your take is on the common saying that Melbourne's a bit of a four seasons, one day place, where you need to walk outside with your raincoat, umbrella, beach gear and winter coat. Is that normal? Is like, given where we are in the world, or I guess polar, I'm not sure what exactly makes an influence on that, or is that something that is unnatural?
It's not unnatural. So it's a good question. Lots of places claim to have four seasons in a day. I think Melburnians are quite proud of the weather that we have here. I mean, it is quite unusual, but it's not, lots of parts of the world, especially in kind of away from the equator, but also away from the North and South Pole, have weather that can be very hot or very cold and sometimes changes quite quickly. Melbourne, though, experiences quite quick changes sometimes. So we've all experienced, especially in summer, those cold fronts where it can be like, 30, 35, 40 degrees. And then a front comes through and, it's dropped well below 20 and, you're freezing.
Yeah.
You're out in like summer gear. So it's definitely, those are quite big changes, but lots of parts of the world do experience quite changeable weather.
Right.
It is like a natural part of Melbourne's weather, though. So even if we hadn't influenced the climate, if we hadn't pumped out greenhouse gases, we would still have very changeable weather in Melbourne. It'd be a bit cooler, but it would be very changeable still.
Right. Yeah. Well, I've always been so curious about that, whether it's something just unnatural, because you go up to Gold Coast and it's just not generally like that. It's like Melbourne, or maybe, I didn't know other places in the world had that, but I guess that makes a lot of sense. You mentioned greenhouse gases, and that's a lot of the kind of rage these days, especially with the Australian election. A lot of people are saying the result was because of the strong climate pledges of certain parties. We've got this huge battle, which is to get this net zero that everyone is plastering on billboards and in their campaigns and as their goal, like this ultimate accolade. You mentioned before we started recording, so you've been working on something surrounding net zero. Do you mind sharing what you're doing there?
Yeah, so most of our climate projections are based on model simulations where we keep emitting greenhouse gases. So we tend to look at what the climate will look like in, say, 2050 or 2100 under different greenhouse gas emission scenarios, maybe quite high emission scenarios or lower ones. But we don't really focus on net zero. We don't really focus on what actually would happen if we do get to net zero, or even go slightly negative with net greenhouse gas emissions. And that's something that we need to know because we're aiming for net zero emissions. Australia is aiming for net zero emissions by 2050, and we're not alone in that goal. Globally, overall, I think we'd be hoping that we hit net zero emissions not too far beyond 2050. And if we do hit net zero emissions, we expect to stop warming the planet. At the moment, we're warming the planet about 0.1 to 0.2 degrees Celsius per decade. We've already warmed the planet overall about 1.2 degrees Celsius relative to pre-industrial levels. We're going to keep warming it as long as we keep emitting greenhouse gases more than we draw down carbon from the atmosphere. If we get to net zero, we stop warming the planet. If we can go negative with our greenhouse gas emissions, so we're actually taking up more than we're emitting, then we start cooling the planet. And that opens up really exciting opportunities if we can get to that point. It requires some technological advances beyond where we're at now. But if, all the policy is around getting to net zero. So if we can get there, we can even go net negative, we can cool the planet and we can kind of target a specific temperature. Maybe we try and go back to pre-industrial levels. Maybe we say, well, we've actually adapted to a slightly warmer climate, so we can cope with half a degree or a degree above pre-industrial levels. Depends. There's an interesting debate that's going to unfold over the coming decades as we get closer and closer to reaching net zero emissions. And it's something that requires some thinking now, because what a future climate looks like beyond net zero emissions depends on our current greenhouse gas emissions and how much global warming we get to at its peak. We need to keep that as low as possible. We need to really reduce our emissions as quickly as possible and keep a lid on global warming as much as possible to avoid kind of the most dangerous climate change impacts.
Definitely. I think what's really fascinating is, you're right, there's no real, what do we do once we get net zero? Like, we're going to have to, if we achieve net zero, well, right now we can see around us, India going through insane heat waves and famines, Mozambique getting plastered with different things. We're threatened with our coffee because coffee needs a certain temperature, and you take people away from their coffee, everyone's going to go insane. So where we are at the moment, and even if we stagnate and we don't emit any more carbon, it's still causing a plethora of problems globally. Like, we're seeing what's happening just up north at the Great Barrier Reef, even through a La Nina year, it's still bleaching 91% of the reef. Like, that is absolute insanity for something that should be good. So my question and point in all this, what do you see life looking like once we hit net zero? And then what do you see life looking like again once we start to reducing it? Because I'm assuming what we're doing day to day, how we're getting to work, what we're eating, certain things are going to have to change. What does the everyday person do in a net zero world?
That's a really good question. I don't think it's something we've thought much about. In order to get to net zero, we're going to have to change how our economy works and how society works. It will be completely decarbonized by definition, almost. We're already seeing that. We can envisage what that might look like in some sectors more easily than others. So in terms of electricity generation, it will be entirely renewable. Maybe in some countries, possibly with nuclear power. But there will be no coal, oil or gas. But in other ways, it's kind of harder to envisage what a net zero world might look like. It will likely involve us eating less meat and having maybe, certainly a more vegetarian diet or maybe smaller amounts of meat or fish. In terms of transportation, it will look different. We need to have more fuel-efficient planes. We'll need to be using electric cars and electric vehicles where possible. And there's all sorts of other sectors which will have to decarbonize as well. In terms of net negative emissions, we're going to be needing to have technology that allows us to really take carbon down from the atmosphere. Some net negative greenhouse gas emissions, so where we're taking down more carbon, might be through land use changes, so through planting more trees. But it can't be in a way that's not sustainable. It has to be in a way that doesn't use up too much land that we need for crop growing. And it also can't be in a way that the trees are allowed to then burn in a fire. So it has to be in a way that's kind of sustainable and resilient to wildfire, bushfire risk. So there's different ways we can get to net zero and net negative, but it will involve quite drastic changes from the way society works currently.
This is really exciting because a lot of people, and as soon as you started talking about all the things we're going to have to change, which I couldn't agree more of, people are always threatened when you bring up renewable energy or you bring up changing the way we live, saying, oh, you're taking away our jobs. That's a really big thing, especially with this coal, gas, fossil fuel sector in total. But what we're describing here sounds like you're rebuilding civilization almost in a new light, new technology. You're going to need more innovations in the aerospace sector, in the general vehicle sector, in the agriculture sector. Almost every single sector are going to need technicians, going to need like the fact that people are scared of their jobs and we're saying we're going to re-innovate the whole thing is like almost like a green industrial revolution. And I don't really see a threat to workers or jobs. I see more opportunities. And I don't know if that's just my optimism, but based on my research and what we need, I don't see a threat to anyone's livelihood if proper jobs are transferred to new industries. Do you?
So overall, I think there will be a lot of jobs in this green revolution, definitely. As you were describing, we need big technological advances, which requires a lot of research, a lot of new manufacturing. So there's plenty of opportunities. To be fair, there are currently jobs that exist that won't exist in a future where we're at net zero. And it's perfectly reasonable for people to be worried about their livelihoods if they're in an area, in a job which isn't really consistent with a net zero emissions future. We do need a plan to retrain people, to reskill people who are in jobs which are just incompatible with a net zero future. So I think it is completely fair for individuals to be worried if their jobs are in areas which just won't exist in a couple of decades' time. But I agree with you. There's lots of exciting opportunities, and I think we see like young people today are really aware of this. We don't really see young people moving into jobs that will be jobs of the past in the not too distant future. We're seeing lots of people here at University of Melbourne and plenty of other places as well. Lots of our students really wanting to work in renewable energy, wanting to work in green manufacturing, and also on the research side, developing kind of new materials that help us to decarbonize our society. So lots of exciting opportunities, but it is fair for people to be concerned as well.
Yeah, that's a very compassionate answer, Andrew. I get it, but I always say like no one's crying for the guy that used to make the wooden wheels for the horse carriages, and hopefully they were transferred. But in a good example, I guess, somewhere close to home, WA's closing up their logging. I'm not sure if you heard, but they're closing up all their logging by December next year, I believe it is. And so the government's gone and given the workers, they've devoted 15 million, and that is to retrain all the workers and to pay their salaries up until they find new work, which is a fantastic real life example, somewhere close to home, and somewhere I'm sure lots of countries should kind of look to, and I'm sure they're not the first to think of something like that. It's not revolutionary. But as a climate scientist, someone who's in the industry, do you look at a certain country or nation and think, yeah, those guys are doing it right, or they're going in a really good direction, or are you kind of like everyone needs like a kick?
That's a good question. I mean, so many small island states and developing countries, which aren't really responsible for our greenhouse gas emissions to date, are already doing okay. Like they're not, they already have kind of good plans for the future. They really want to keep global warming to very low levels because it tends to be the poorest countries that are suffering the most, and those low-lying island states in the Pacific, in the Indian Ocean. So they're doing the right thing broadly. In terms of the big emitters, so countries like the US, China, groups of countries like the European Union, some are doing better than others. In Europe, there's definitely more ambition around reaching net zero emissions than there is in some other countries. I wouldn't say, though, that any of the big emitters are, doing a wonderful job. Like they're all, there's room for lots of improvement. And, they're all signed up to the Paris Agreement, to try and keep global warming to very low levels. They do have plans in place that go towards us maybe keeping global warming below 2 degrees, just about. But it does require more effort. And as you pointed out, we're at 1.2 degrees global warming now. We're seeing bleaching on the Great Barrier Reef in a La Nina year. We're already in a lot of trouble. We need to act as quickly as possible because we're already experiencing unprecedented extreme events that are severely damaging ecosystems and worsening people's lives as well. So no big emitter is doing as much as they could be, but in the last few years we've seen lots of countries moving in the right direction, including the US since a change of government there, and Australia's also just announced stronger emissions reduction plans, and that's great. It's not enough for us to be consistent with keeping global warming below 1.5 degrees. We need to do a lot more, but it's a good starting point.
Yeah, got to reward the small steps, but not lose sight of the true goal here, which is to avoid our suffering, really. Now, you mentioned the Paris Agreement. That's something I found really fascinating, how countries have come and kind of, some have made a fool of themselves, Australia included in that batch, and then others have really kind of taken that, but none have really gone above and beyond. And when I'm just reading about the COPs and what's happening there, I kind of feel like they're all waiting for a leader. Like no one's really stood up and be like the big version of Bhutan, like they're carbon negative, I believe. Not that they have any big industry, but someone's waiting for something to happen, something big to occur. What do you see that COPs need? Like, what's the kick in the butt?
Yeah, I think you're right, by the way. I do think a lot of countries have looked for to maybe the US, maybe Europe, maybe China for leadership, and they haven't really seen it properly. I think they are being given that kick up the butt, really, because the public in lots of countries around the world are really worried about climate change. We've seen that in Australia recently with the change of government, but we've also seen that, we also see that in other countries as well. So I think governments are moving, governments know that they need to respond to the problem better than they have been, and they are trying to do that. I think the one issue with climate change is that there's always, it's viewed as a long-term issue, and there's always kind of short-term problems that come up and divert attention. And some of the possible solutions to those shorter-term problems are sometimes at odds with the longer-term goal of decarbonising our economy. So, for example, with the crisis that's going on in Ukraine, homegrown energy resources are seen as a positive, definitely more of a positive, and there's discussion of opening more oil fields in the North Sea, for example, or even some people suggesting reopening coal mines in Western Europe. And obviously that would reduce dependence on energy imports from Russia, but it doesn't help the long-term goals of limiting global warming. So we need to be thinking about how to make our society and our economies more resilient, so that we don't suffer as much when we have these kinds of shocks, these events, but equally we move towards decarbonising as quickly as possible. And indeed, if we had higher dependence on renewable energy in Western Europe, there would be less of a need for those Russian imports. So, but it's harder to build that capacity very quickly. 100%.
There's so much change that needs to happen. I mean, one change I know that Australia, and I think Europe especially, needs to employs, if they're going to use fossil fuels, actually having storage solutions, so that in a future situation such as this, they don't need to rely on import, they don't need to rely on exports, they don't even need to rely on drilling more oil, because they have this compulsory reserve they must keep, and that would help in a sort of energy crisis like this. But I want to touch on the decarbonisation. That's a really complicated field, because let's look at the IPCC. We can see, like roughly 29% is attributed to like the building sector, stuff like steel, concrete. We've got 18% agriculture. I think it's like 10% of transport, and so forth. There's a lot of categories, and within that category is even more categories. So where do you think, of course this is going to be different nation to nation, but what is the low-hanging fruit that we should potentially address first or look at first? Maybe somewhere where the technology is already available for that change to take place.
I think the big areas where we do already have the technology are the electricity generation, obviously. Like we know how to generate electricity from solar power, wind, hydroelectricity as well. And we have had that technology for a long time now. It's improved as well. There's basically no excuse not to really push hard to switch to renewable electricity generation. We're seeing as well at the moment this boom in electric cars, and that's exciting. I think that can go a bit harder. Like we could have more ambitious targets around switching to electric cars.
Do you see a problem with like the mining side of things? How do you think about that whole mining cobalt and manganese and that kind of stuff?
So we will always still need some of these precious metals, but we can do this in a more sustainable way and a more climate-friendly way. There's going to be a whole range of improvements in technology needed for different sectors. You mentioned construction, concrete, for example. We need to find solutions where we develop technology that allows us to keep building. We need to be able to build things, but in a carbon neutral way. So that needs to be developed. We don't have that yet, really, on scale at least. We need to be able to develop that ASAP. So we need a kind of a whole range of different solutions. There is definitely lower hanging fruit in some areas, definitely electricity generation, for example. Mm-hmm. But in other areas, we need to pursue technologies that allow us to decarbonize as quickly as possible. But, humans are very innovative when we need to be, and the world changes quite quickly. Mm-hmm. So it's very hard to predict in 20 or 30 years' time how these industries will look. But they need to be more energy efficient at the very least, and preferably carbon neutral if possible.
Energy efficiency is a great way to really tackle a lot of things, because energy efficiency is a big father category in the way that I look at it. I mean, energy efficiency could be putting green roofs on buildings so that less heating or cooling is needed because it's better insulated, actually properly retrofitting buildings with these new LED lights instead of the incandescent. I always struggle with that one. Doing these kinds of things I've always found to be really low-hanging fruit, and it blows my mind that there aren't more initiatives. I actually even read in Melbourne they're building the first climate, it was like carbon negative building ever, and the whole building is going to be plated with solar panels. And I'm like, that is insane. It's going to cost something like 25 million, like a stupid amount of money, but that's just cool stuff that humans can really come up with. And like you say, when our back's against our wall, that's when I'm imagining in my mind we're actually going to stay under the 1.5. I think we'll get to like 1.49, and then humans will decide, all right, that's too many people are dying now. People are losing their livelihoods. Let's turn it around. That's kind of how I see it going down.
I'm less optimistic. I think we're going to go through 1.5.
Yeah.
I think if we work really, really hard, we'll stay below 2 degrees global warming, and we'll hopefully be able to come back down fairly quickly from our peak level if we really implement net negative emissions technologies. But, until recently, if you asked most climate scientists where are we heading in terms of global warming, I think most would have said nearer 3 degrees global warming. We have seen this increased ambition with the Paris Agreement, and since then, with the COP meeting in Glasgow last year, we are seeing our leaders need to do more, but they are moving in the right direction. So I think there is a bit more optimism, but I'm not as optimistic that we'll stay below 1.5. I think it's unlikely we'll stay below 1.5.
And it's just a matter of people aren't listening to the science, because I heard my friend say this once, and I'm like, isn't that so true? When COVID kind of first occurred, the governments were like, all right, what does the science say? They're like, this, we have to know what to do, how to tackle it. Are we wearing masks? What are we doing with the lockdowns? How are we addressing this issue? And then when it comes to the climate emergency, we're like, nah, for a long time, it was climate denial. And now it's like, oh, well, we're not denying it. It's like that tobacco kind of media play. And we're just not listening to the science, I feel. And I think you might relate a bit more about that than I do, especially with the recent news. Like, yes, we have the film, like Don't Look Up, that came out, we were just talking about before. And then a few months after there is a release, a climate scientist sets himself on fire, because all I hear about is interviews of climate scientists saying, I got into this field to make the world better, but then I realized nobody gives a crap. Nobody's listening, or the right people aren't listening. The everyday people, yes, are. And is this change, which I will admit, 10 years ago was a lot less prominent, I think. And you've been in the industry for 13 years. Well, you've been studying for a while. How have you seen the shift, and how frustrated are you when it comes to like news outlets?
Well, okay. I mean, firstly, there's quite a lot of variability between news outlets. Like, some are better than others. But yeah, it's definitely frustrating. We see extreme weather events that are being exacerbated by climate change and having huge impacts. And, we go on TV or we go on the radio and we explain this, and, we can say things like, climate change is worsening this heat wave. We're going to get, 50-degree days in Sydney and in Melbourne within the next few decades. We're going to see the loss of the Great Barrier Reef. And it kind of feels like, these are really big, especially the loss of the Great Barrier Reef. This is, an ecosystem that was once extremely diverse and was something that Australia was very proud of, and we're basically killing it. And you kind of go on the media and say this, and it kind of feels like no one's listening, like people move on very quickly to some other news story. And it is quite disconcerting that it kind of sometimes feels like people don't really care, that we're losing a really important ecosystem in the case of the Great Barrier Reef, or we're really changing the planet beyond recognition in some ways. And it's definitely quite sad that I think most climate scientists kind of build up have to build a bit of apathy, in a sense, to what they're saying, because it's really depressing often, what we're reporting, what we're finding. And it's incredibly sad that people often don't seem to care. And the other thing that's frustrating is when sometimes we have extreme weather events like heat waves, which we know are one of the biggest killers in Australia in terms of natural disasters. We get far more deaths from heat waves than we do from flooding, for example.
For humans?
For humans in Australia. And, we'll go on TV and we'll talk about these, extreme record high temperatures that different parts of Australia may be experiencing, and how climate change is making them worse, and how, these are really big problems. But they're often coupled with images of people playing on the beach, or people, really enjoying the sun. But that's kind of sending the wrong message. Like, these are deadly events, and there are people really suffering, especially elderly people or very young people, very young children who are more susceptible to heat stroke and heat-related illnesses. And, we see spikes in mortality in hospital admissions during heat waves. And, it feels like that's because it's not really visible that those people are dying because of heat. And climate change is likely increasing the number of people who are dying because of heat. Because it's not really visible, people don't really seem to care, or maybe don't comprehend the problem. So that's another kind of frustrating aspect of being a climate scientist and talking to the media. There's also kind of the general issue that some media take climate change more seriously than others.
It's hard. It's like you can't stamp someone with cause of death climate change. You can't do that. And you're right, there's so much that becomes affected, not just heat waves, but like I was talking about before or maybe it was during the recording, about the coffee beans and how that's going to affect 27 million livelihoods, these people what about the ones in Nepal, that their sustenance farming's getting ruined because of the floods that are coming through, and not even mentioning the Madagascar famine and all these certain things. That the deaths via climate change are just going to overtake the deaths via undernourishment and these certain huge, and I'm not even sure if a certain amount of undernourishment is due to climate change and limited crop deaths. Like, the amount of people that are dying due to malnutrition is absolutely staggering. It was something like 1,000 children a minute. Like, it's some stupid number like that. And you kind of have to think, what do you need? Because what does society need to really take this seriously? And when I'm talking society, I have a certain, yes, individuals can do a fair bit. I think more than what we choose to accept credit for. I think the mentality of I can do nothing because I'm one person is incredibly toxic and not necessary here. But I don't know. I always think, who is needed to do this? Like, who is the Martin Luther King of this issue? And yes, we can look at Greta Thunberg and then we see, okay, nobody listens to her. They clap like, oh, Greta, let's get a selfie, but nobody's really following through with making these real changes. And the more I talk about it, and I've kind of made that decision to not call it climate change, but a climate crisis, is because I think there's three levels, right? There's people who underestimate, and there's people who roughly get it pretty good, and there's the people who really understand it and think like alarm bells. You need to wake up with those alarm bells sounding every day, and that's super doomsday. And I hate to think like that, but the more I get educated on the topic, the more I think that's kind of what it's like. Like, you feel like there's just alarm bells, and you have this certain level of climate anxiety, especially if you're aware. And I'd imagine those like yourself working in the field have a very severe case of this anxiety.
Yeah, I think that's true. I think, to be honest, I think many scientists become kind of numb to it because you basically have to keep going in this area. It's, it's hard to, you can't really be anxious all the time. So, I think you're broadly right. Like, it's definitely, it feels like the people who understand the most are the most alarmed. I think there are some instances where people are too alarmed, or sometimes, not many, but there's definitely instances
that
we see.
Subpopulation.
There's a very small fraction of the population that is like, imagining things really, really, really bad, beyond our predictions.
Kind of like that movie 2012, if you've ever seen that.
Yeah, I saw it ages ago.
Where like tsunamis are just coming and taking over cities, and everyone has to get into their bunker. And
yeah, I mean, that's, so this is not, some of these disaster scenarios are not realistic either. But I mean, the reality is bad enough. We are projecting much worse heat waves, much more frequent, more intense heat waves, the loss of the Great Barrier Reef, more intense bushfires, more frequent bushfires, more droughts in many places, more extreme rain and flooding in many places, and a lot of sea level rise and coastal inundation. And that's bad enough. All of those things are bad enough. What keeps me going is that we are moving towards, very slowly moving towards getting on the right track. Our greenhouse gas emissions are way too high still, and they're still just about near record highs globally. We need to bring them down very quickly. But we are turning the corner. We are seeing more people concerned about climate change. We're seeing more leadership. There's
a glimmer of hope there.
There is a glimmer of hope, exactly.
So part of the hope for me is knowing that, like I said at the beginning, individuals have an opportunity to do everyday things to reduce their carbon footprint, and however big or small that may be, an impact is an impact. And you mentioned earlier that one of those solutions is reducing our meat intake. Now, most people who listen to this, we talk about it quite a bit. We can't ignore the fact that agriculture plays an enormous part of our lives, whether that's those really carbon intensive, whatever food that's flown by aviation, or whether that's a food that takes up a lot of resources such as beef or dairy or pork, these high carbon intensive foods. What is the understanding between climate scientists when it comes to this field? Because I know it's very triggering for a lot of people when you try to change what they know. And I guess there is an understanding within your field of, we know that we need a change. So there's less of that triggeringness or more of that wokeness. But how do climate scientists, or at least people in your atmosphere, feel about things like vegetarian or plant predominant Mediterranean diets even?
Yeah, that's a good question. I think, many climate scientists are vegetarian, I would say, a higher fraction than the overall population. And partly a major motivation for that is, we understand that eating meat is, raising livestock is a major source of greenhouse gas emissions. It's also kind of a personal choice as well. So I think most climate scientists don't really talk too much about this, or and don't advocate too strongly. But we try and just point out the things that people can do to reduce their greenhouse gas emissions on the personal scale. I agree that individuals do have power, although I think our biggest effect is through influencing governments to change policy tracks. But in terms of things we can do in terms of our own lifestyle, I think being vegan or vegetarian helps a lot. Obviously, vegan is better than vegetarian in terms of greenhouse gas emissions, or certainly at least just reducing meat intake. So if you're eating meat every day, but just going down to once or twice a week makes a big difference as well. So there are steps that people can take, from their existing diet. Just making relatively small changes can make a fairly big difference. I think a lot of, as I was saying, a lot of climate scientists have become vegetarian, I think, in the last few years.
I think a lot of them would be excited about the concept of like cellular agriculture, and I guess meat that's made in a petri dish that's cellular, just the same as what an animal would be, but the water and land resources are, depending on the study you look at, 97 to 98% less. So there's a lot of amazing innovation, and it's good to hear that. I mean, less so that there is conversations among peers, and I'm sure there are in some circles, but especially climate scientists, if anyone looks to an example of what it means to be climate friendly, and I don't know if you'd agree, I look at like a lot of metadata analysis and even Our World in data.org, I'm not sure if you're familiar with them, but I would argue to a vegetarian that I would almost prefer them to be a vegan with chicken, because of if you're looking at a purely environmental standpoint, because dairy is such a mammoth of an emitter, because one dairy cow needs at least 2 acres by law of land, let alone the water used. So I always find it fascinating, like ethically and healthily, that's a different conversation, but I always find it funny that I forgot which climate scientist I was speaking to, like, I'd prefer someone to be a vegan and have their chicken instead of a vegetarian that consumes the average or slightly more than the average person would in dairy.
That's interesting. I think, we don't try to be too strong in what we say people should eat. People don't really like to be told what they should eat.
Is that obviously why you don't like saying it?
Probably. Yeah, I think so. That's a fair point, definitely, that if I think in general, if people think about or gain awareness and knowledge of the greenhouse gas emissions associated with different aspects of their diets, and then seek to make improvements, I think that's a big step. Obviously, there's kind of health factors as well, of course. So it may not be suitable for everyone to do, to suppress or to change their diet with the only goal being suppressing greenhouse gas emissions as much as possible. It's kind of, there are other factors that people need to consider when.
Yeah, got to look at it through a holistic lens.
Exactly.
Is where we're kind of going. Yeah, I love that. A lot of really what I wanted to talk about initially today before we're even 50 minutes in and I haven't looked at my dot points is actually weather patterns. It's something we actually haven't touched on the show before. And I've read recently in some articles about these atmospheric rivers and this stuff that's incredibly confusing to me as a layman. I don't really understand how this all works and why that is even relevant to the way that our climate is and even the floods that are happening not only in Australia, but from what I understand, atmospheric rivers are literally around the globe. So could you give us a rundown on what they are and how they affect the way we live?
Before I discuss atmospheric rivers, I'll just take a step back. We have different weather patterns influence our day-to-day weather. So when we have higher pressure, we tend to have drier conditions and sometimes warmer, sunnier weather. When we have lower pressure, we often have rain bands, like troughs or fronts, where we get bands of rain and stronger winds and changes in temperature. So we have these weather systems kind of going around in bands around the world, including places like Melbourne and southern Australia generally. Atmospheric rivers are a type of weather system where we get kind of a flow of very moist air in the atmosphere, so way up above our heads.
How high are we talking, by the way?
Kind of a few kilometers.
Okay.
So not super high. So kind of
above the clouds.
So from around, well, you get different heights of clouds. So it's kind of the lower clouds, the heights of the lower clouds up to the heights of the highest clouds.
Yeah. Okay.
Kind of band. And we get this very moist air, and it tends to flow from the equator, either side of the equator, so towards the north and the south poles. But it kind of gets deflected by the rotation of the Earth. So we get atmospheric rivers typically in the southern hemisphere that come from the equator and kind of move southeastwards. And they often bring heavy rain because they interact with other weather systems and result in heavy rain events. And during the floods in eastern Australia, we saw atmospheric rivers affecting Queensland and New South Wales, where we'd have a band of very moist air coming in towards the east coast, so actually kind of going the opposite, slightly a different direction to the standard atmospheric rivers, and interacting with kind of lower pressure at the surface to bring really immense amounts of rainfall. And we think atmospheric rivers contributed to the severe weather, the heavy rain that we saw earlier this year.
And then looking at that concept, it sounds like a very natural phenomena. I'm assuming at some level, well, we've put so much CO2 in the atmosphere, the whole global ecosystem has been affected one way or another. Is the global river atmosphere or river air, what do we call it again?
Atmospheric rivers.
Yeah, atmospheric rivers. Are they exacerbated or made more dangerous in this way because of climate change?
So this is something that's being researched. If we didn't increase the amount of CO2 in the atmosphere, we would still have atmospheric rivers. So if we went back to pre-industrial times, we would still see these systems. We think through modelling the climate and changing the amount of greenhouse gases in our modelling simulations, we think that climate change is probably worsening atmospheric rivers, intensifying them so they can carry a bit more moisture. And it's also probably changing the positions of these systems. But there's a lot of uncertainty. We need to do more research. And it's really important because in Eastern Australia, especially we've seen the effects that they can have. It's really important that we understand how atmospheric rivers are changing in order to understand our future flood risk in places like Lismore or generally across eastern Queensland and New South Wales. But at the moment, we have quite a lot of uncertainty. We think that they're probably going to become a bit more frequent overall.
Is there a way we can, this is sounding super utopic of a question, but send those atmospheric rivers to the desert, like the Australian outback, where there's no rain and it's just drought?
No, we can't really intervene on that scale. These are quite major weather systems.
Right.
So we do get atmospheric rivers that bring important rainfall to the desert and to places like the Murray-Darling Basin. So actually, often atmospheric rivers are a good thing. They bring much needed rainfall in some places, but in other cases they bring severe flooding. So we don't, any kind of change where we try and change weather patterns is extremely, it's very hard, but it's also extremely risky. And, moving, if hypothetically, suppose we were able to move weather systems around where we wanted them to be, so we could move more rain-bearing systems over the deserts in Australia, that would probably also affect weather systems around the southern hemisphere, and it might mean that we cause floods in some other place.
We could affect South Africa.
If hypothetically, if we were moving weather systems around, we could be doing that. So we don't really want to have that kind of influence. There's a whole. This is maybe digressing slightly, but there's a whole area called geoengineering where we think about how we could try and reduce global warming, but without reducing our greenhouse gas emissions. So one example of doing this is through spraying salt from the sea into the atmosphere to develop more clouds and reflect more radiation that's coming in from the sun straight out into space. And, we could probably do this and it would have a slight cooling effect. But just by having that causing that kind of change could have quite severe unintended consequences. So the very best thing we can do is just reduce our greenhouse gas emissions and really work to influence the climate less, not in compensating
Band-Aids and playing God.
Exactly.
And, I did read something that China had this special day of celebration, so they influenced the weather to be sunny or something like that. I forgot the weather they influenced, but they have some sort of system where they...
Yeah, so you can do things like cloud seeding, where you try and basically clouds form when you have particles in the atmosphere that water condenses onto. And if you have too many particles, the water gets kind of shared out too much and you don't get clouds forming. So if you spray more particles into the atmosphere, you can suppress, in theory, you can suppress cloud formation. And that's something people have tried to do, not just in China, in other places as well, including in Australia in the past. And it's hard to tell if it's worked because we don't know exactly what would have happened if we hadn't done that, because we don't have...
There's no placebo here.
Yeah, exactly. There's no control kind of. So it probably does work a bit, but it's very hard to tell.
Awesome. Well, it's coming on the end of the episode. I want to give you a chance to just talk about some myths in the climate area, if you know any, maybe something that the public commonly believes that is just wives' tale. If you have any, if you don't, then I'm happy.
I'm sure there are some. I haven't I'll need to have a
like
bit of a think.
Like in my example, like I'm plant-based, so I always come across, but protein though, when plants don't have protein, that kind of argument, that common myth that goes around. And I'm sure there's one, besides climate denialism, I was wondering if there's any other like common things you have to debunk, like common student questions that are like, no, sit back down.
There's definitely, I mean, there's kind of standard things that I'm sure you've already heard before. So, people will sometimes say, we can't predict the weather more than a few days ahead. How can we predict what the climate will look like in 100 years? So there's that kind of thing. And the reason we can do that is because if we're looking at the climate in 100 years, we're not trying to predict the exact weather on a given date. In 100 years' time, we're looking at the general conditions, and those are related to our greenhouse gas emissions predominantly, whereas in terms of weather patterns, we're interested in when weather events will occur, when rain will occur, say in a few days' time, and that's more dependent on the exact positioning of weather systems and how they track forward in time, and that gets more uncertain the further ahead you go. So we care about different things in terms of weather and climate.
You don't care if it's 29 on one day and 30 in the next.
Exactly. So that's kind of the type of myth I encounter quite commonly. I guess another one, which is a bit of a change from previous positioning in terms of climate science, was that we can't attribute any particular extreme weather event to climate change. So it used to be said that when we have heat waves, we can't actually say climate change contributed to this event. But the science for that has moved on in the last decade or two. So when we do have heat waves, we know from our analyses of heat waves in Australia and elsewhere that they're becoming, we could say that they're becoming substantially more likely and more intense because of our influence on the climate through our greenhouse gas emissions. So that statement that we can't attribute a specific extreme weather event to climate change isn't really true anymore. Equally, we don't say that climate change caused an extreme weather event. We can say that in the case of extreme heat, climate change greatly increased the likelihood of this event occurring. We can often say that quite quickly after an event. So I guess that's another myth that I encounter quite often.
I mean, I'd like to give people a resource to maybe do their own research in tackling myths. Where do you usually point to people as a resource for proper information on climate change? I mean, I usually look at like carbonbrief.org, or I look at the IPCC, these kinds of, that's really information heavy. And yes, they do their dot point formats, which is generally where I live, but they have some really good information. Are there any other resources that you like to look at for up-to-date information?
Those are both really good resources, Carbon Brief and the IPCC. I think things like the Conversation website
you write
podcast.
at the Conversation, don't you?
I sometimes do.
Any of your articles are good.
I would say this, but it's lots of climate scientists write for the Conversation, and there's lots of really good information there. And it's been around long enough now that if you've got a specific question, it's probably already been addressed in one of these articles. There are some. I think the main advice I would give is to not just trust everything you read immediately. Think about the source, think about the credibility of the experts that are being interviewed or have written the article. So, for example, I saw recently in one news outlet that people were discussing the cold start to winter and the snow and using it to try and debunk the IPCC and human-caused climate change. And they were quoting...
I can't.
It's silly, but they were quoting people who aren't experts in the field,
quoting like climate information from a nutritionist, that kind of thing.
No, they weren't quoting nutritionists, but they were quoting people who aren't experts or who may claim to have expertise, but they don't. So think about the qualifications of the people your media sources are relying on, and be quite careful in how you interpret those. So generally, articles from sources like the ABC are broadly good on the whole, and the Guardian website is pretty good as well. So in Australia, those are two fairly strong media outlets for mainstream media outlets for climate information. We know that quite often some of the other newspapers, including the Australian, don't have published erroneous articles in the past.
And Sky News and Sydney Morning Herald, just to add those two. We don't mind name calling here.
Okay. I would say with the Sydney Morning Herald and the Age, leaving aside recent controversies, generally, many of their climate articles are fine. Some of them, maybe historically, some of them not so much, but more recently, most of them have been fine. I know they've had other controversies at the moment.
Awesome. Look, I want to get one more bit of wisdom from you while we can. Now, we've talked a lot. This episode has kind of gone on many different rails, which I'm really stoked about. But I wanted to give you the opportunity. I like to finish this with all the conversations that I do have, with giving you 1 to 2 minutes to completely control the platform. I want you to leave us with one more golden nugget, one more word of wisdom that could be relevant to what we talked about today, or could be something completely irrelevant, something that's been on your mind the last day, 2 week, or maybe even the work that you are up to that you're really excited about. The stage is all yours for a minute or two, Andrew.
Okay. How should I best use my minute?
Take your time. You can go more than 2 minutes, okay? It's just how I frame it.
Okay, I think there was actually a really interesting discussion about this on Twitter the last few days. One thing I think many climate scientists have realized is that there are things that are well understood in our field that aren't well understood outside our field. And one that someone pointed out is around kind of our greenhouse gas emissions and global warming. If we keep emitting greenhouse gases, we keep warming the planet. So even if we reduce our emissions, say we reduce our emissions 50% next year, that's not going to happen. But hypothetically, we did, we would still be warming the planet. So I think people don't realize that. We need to actually go right down to net zero to stop warming the planet. We could reduce our emissions 80%. We'd still, in the long term, be warming the planet. If we reduced them by 80% and just held them constant, we would still be warming the planet. We need to get to net zero to stop warming the planet, and we need to actually start drawing more carbon out of the atmosphere than we put into it through our emissions to actually start cooling the planet. And I think maybe this isn't, I've realized that this isn't widely known recently. And that's quite alarming because this is like a fundamental aspect of how the climate works. So even though, I was talking about earlier being a bit more optimistic and hopeful given recent developments and the fact that we're seeing stronger pledges on emissions reductions, we're talking about something where we're reducing greenhouse gas emissions in the next few years a bit more than we would have been otherwise, but that is still warming the planet. So it's kind of like if you have a fire, at the moment we're throwing wood on the fire and the fire's getting much worse.
We can just use the word coal since that's literal.
We could use coal. Yeah. And if we reduce our emissions, say by 2030, we're talking about reducing our emissions now by over 40% in Australia, and in other countries aiming to reduce their emissions, we are still throwing coal on that fire, just a bit less. So we're still worsening that fire. We're still warming the planet. It's not until we get to the point where we're not throwing coal on the fire, where we're actually just not, we're at net zero. It's only then that the fire stops growing. And then it's only when we start to kind of try and extinguish the fire that the problem starts to ease. So we're going to hit our peak global warming when we get to around net zero emissions. So because we're still warming the planet. So we have a huge amount of work ahead of us. Our greenhouse gas emissions are at just about record high levels. So we are shoveling that coal onto the fire very, very quickly. We're making things much worse very quickly at the moment. We need to turn that around urgently, as quickly as we can. We need to reduce our emissions to net zero as quickly as possible. It's not something we can push down the track. We have to do this as quickly as possible. Every few years of delay means much worse climate change impacts down the track, especially in terms of things like sea level rise, which are not really reversible on timescales that we care about. So this is an incredibly urgent problem, and we are a very long way from where we need to be. So that was way more than 2 minutes, but
it's an important 2 minutes. It felt like 10 seconds because it does speak to it's actually a great way to end the episode because, we've got work to do. We can finish this conversation, take for the audience and the whole community members, for myself, for yourself, to go back to our friends, our family, our community members, continue this conversation and start educating the public on how we can make a positive change yesterday. Australia has made a huge stride, and with the big Brazilian elections coming up, I'm hoping they make another huge stride because they are incredible emitters due to their agriculture and logging sector. So there's lots of conversations for us to be had, and I think that's a really important take-home message. And I wanted to finish up with a thank you. Like we mentioned before, climate scientists don't always get a lot of praise. So I wanted to extend a personal thank you to yourself, Dr. King, for doing the work that you do, not only the publications that you do put out there, which I've read a few and they're fantastic, but also given that we all have spent this last hour or so with you, I think a lot of us listening are quite confident in the fact that we're glad you're out there teaching students to look at things through a lens that's very intellectual and that can make these positive differences through the research and point us in a direction where we can make these innovations at a very impactful level, because it is very much needed. We need everyone to take the nuggets that you dropped with us today and really continue those conversations. So I really do have a deep thank you for not only coming on the show, but for doing the work that you do. If someone wanted to reach out to you, you mentioned Twitter, is that the best place to go?
Twitter or email is fine.
Cool. I'll leave both of them in the show notes for someone to get connected with you. But thank you again so much for your time today, and I'll speak to you soon.
Thanks for having me.
Hi there. Welcome to the end of the episode. Thank you so much for listening and or watching the whole way through. Thank you once again to Dr. King for coming on and sharing your wisdom. I think it was a super insightful episode, and I'm really excited for the potential impact that it has given each and every one of you, even if it's one thing that you have taken away, one perspective shift or whatever that may be. If you wanted to connect with Dr. King, I've left the links and details on how to do so in the show notes below. But besides that, I hope everyone has an incredible week, and I'll see you on next week's episode. Stay happy, eat plants, peace.